Alright, welcome to this evening's notes. This one is about extrema. Our essential question is, what are extrema and how do we determine them? Extrema refers to the maximums and minimums of a graph. A graph can have more than one maximum and it can have more than one minimum. It can also have no maximums and no minimums. Relative minimum is the lowest point in a particular region of a graph. You can sometimes have more than one. Sometimes you'll have none. But again, it's the lowest point in a particular region. So you might have 3 or 4 regions, and you might have 2 or 3 minimums. Absolute minimum. The absolute lowest point for the entire graph. You can only have one of these. You might have none of these. If there is an arrow going to negative infinity, if the end behavior is approaching negative infinity, then there is no absolute minimum. So an arrow negates any lowest point that you have. It keeps going, never reaches it, so it's not an absolute. Relative maximum, the highest point in a particular region, and once again you can have more than one. Absolute maximum, the highest point for the entire graph. Just like with the absolute minimum, infinity is not a point, so it can't be an absolute maximum or a relative maximum. And remember that you will either have one absolute maximum or you will have no absolute maximum. So if you have an arrow on the end that goes up forever, there will be no absolute maximum. Alright, so now we're going to take these definitions and we're going to do a couple of examples and then the notes will be done. So go ahead and pause, finish copying your notes, and then come back and we'll finish with a couple of examples. Okay, example number 1. We want to determine the extrema for the following graph. So the first thing I'm going to do is I'm going to look for my relative minimum. Relative minimum is going to be the lowest point that I can find in a particular region. So right here in this little area I see this low point, and it's located at -2, -2. So that's going to be a relative minimum. Now, is it the lowest point on the entire graph? If it is, it's my absolute minimum. But because of this little arrow that's going down forever, it's not my lowest point. Now, the arrow is also not my lowest point because an arrow is not a point. So for absolute minimum, I would put none. Because there is no lowest point on this entire graph. This point right here is lower than this point here, so -2, -2 is not the lowest. But because of the arrow, it keeps going, so I never get to the lowest point. So there is no absolute minimum. Now I'm going to go figure out my relative maximum. My relative maximum is the point -6,4, because in this particular area of the graph, -6,4 is the highest point. It's at the top of a mountain. Now, is it my highest point on the entire graph? And again, the answer is no, because of the arrow that continues to go up. So for absolute maximum, again, the answer is none. Because the arrow indicates that the graph continues to rise higher, and so it never gets to the highest point. Now, one word of caution. Occasionally, you'll have a graph drawn like this, where you might have a point that appears to be lower. This point down here appears to be lower, but see that little arrow right there? That arrow indicates that this continues to go down. So if you see a graph like that, they're trying to trick you. You need to go to that arrow and just extend it so that you know that it's below your lowest point that you have. So just be wary of that. Sometimes they will do that to trick you. Alright, that's it for example 1. Go ahead and copy it, and then we will finish up with example 2. Okay, second example, last example. Here we go. We want to determine the extrema of this particular graph. So let's start with our relative minimum. You'll notice that I have two areas where I have low points. This area right here and this area right here. On both of them, the bottom of the graph is touching the x-axis. So this particular point here, that point is, I don't know, I didn't put the marks on it. We'll call it -2, 0. And on the right side, we'll call that one +1, 0. So I have two relative minimums. Now, neither one of them is an absolute, because remember, with an absolute, you can only have one. And because they are both at the same depth, they're both at the same level as far as their height, neither one is lower than the other one. So both of them are relative, but neither one is an absolute. So for my absolute minimum on this one again, I don't have a lowest point, so my absolute minimum is going to be none. So now we're ready to do our relative maximum. Well, when I look at my relative maximum, I actually have three areas where I have a highest point. I have a highest point right here for this area. I have another high point right here, and I have another one over here on the right side. So I have three regions that have high points. So what I need to do is figure out what are those particular locations, what are those points, what are their values, and what's the ordered pair. So this first one over here, we're over at -3, and we're going up 1, 2, 3, 4, 5. So my first relative maximum is -3, +5. That is a relative maximum. Second one, that's at about -1/2, +1. That is another relative maximum. And then my third relative maximum is at 3, 1, 2, 3, 4, 5, 6. Now this one, because it is the absolute highest point on the entire graph, is not just a relative maximum, it's also an absolute. And if it's an absolute, that's all we have to list it as. So 3, 6 is an absolute maximum, whereas -3, 5 and -1/2, 1 are relative. They're maximums in their area, but they are not a maximum for the entire graph. So the absolute maximum is 3, 6 because it's the highest point on the whole graph. And that's it for your notes. Enjoy your evening. Have a good day. Good night.